Okay, in this video I'm talking about how to make my type of ion engine. Please be kind because my English is not very good, because it's not my mother tongue, of course. And it's not as I'm not making any effort to make myself clear, but it's just the way it is. So, let's do it. My type of ion engine uses microwaves to ionize the air, and then magnetic fields, radial magnetic fields, to make them slide, to make the ionized air or fluid slide through these waves and make a sort of cycle like other engines that have the Brayton cycle or other cycles, but this is not a thermodynamic cycle. It's an electric or electrodynamic cycle. I don't know how to call it. And this is how I use some of the energy of the particles or the fluid of the velocity of the fluid or the particles to ionize even more air, because all the engine is in a resonance mode, so is flowing the air with more let's say with more fluid, with less velocity. So instead of going in a very high velocity, like it happens with all the ion wind engines, the thing is that this engine tends to go with a less velocity but with more ionized air. So it has more, let's say, efficiency, because it's like a reactor, right? A turbo reactor, for example, a turbofan uses a larger fluid capacity, or a turbo helix, a turboprop, a turbopropeller uses a large amount of fluid, and it accelerates less than a turbo engine of a fighter, for example, that uses a less fluid, but it accelerates it more with more velocity. So it's more efficient to accelerate less the fluid but accelerate more fluid, and that's the idea, the main idea of my ion engine. So let's go to the parts of this ion engine. This ion engine consists of an outer shell that is ferromagnetic. For example, I used in my experiment, but you want to use what you have in your house or is available to you, a ferromagnetic material of a tuna can. So a can of tuna fish, it was used to do this outer shell, and this supports for supporting the core and the machine are made in my engine are made of plastic straps. So you will see in other videos how I did the engine, but that's not the thing. Here I will explain all the parts that consist that have the engine. So this is the ferromagnetic outer shell that has to be ferromagnetic in order to not let escape the magnetic radial flux. And this is the core that has, if I hide, for example, the outer nacelle, I hide it with the supports. This is the main part of the engine and the most important, and this have the things to make it work. Of course, here is not represented the polarity and the cables needed to give electricity to this engine. At this you have to figure out that it has to have 2 points here and here, for example, when I click here and here, but in the going through this green and this green parts, the core flux and the core flux nacelle 2 and the core flux nacelle 2 and the core flux nacelle 1, and these core flux nacelles, I call it like that, but maybe it's not well named. But these core parts are made. If you see this, you will have an STL for, of course, of these 2 parts. So these 2 parts I have made it in a transparent, not conductor material, so like resin or transparent resin. I have to do it with transparent resin. This transparent resin allows the electromagnetic waves and other things to escape. That I will not explain everything in this video, but you will have more material in my channel. I'm making a channel, yes, even if I'm not very good at doing videos, but I wish to do this engine because I cannot pass from 2 volts to up higher, so I wish to do it with this. So you will try at home, and if you want to, and let's see if it works. So if I quit the outer nacelle, you will see that this nacelle, this part, has other main components, like for example the RF cavity. Sorry, there is a radio frequency cavity that has this shape, this strange shape. If I hide this, for example, you will see that has this strange shape. It's only this. I will hide these other parts, and you will see it has this shape, and it has an opening here. This goes all the if you discharge, if you download, I think that's the word. If you download the parts in your and you print them in your printer, into your 3D printer, that I think you will need a resin 3D printer, because you have to have a transparent resin. So I made it with my 3D printer. It's not a very cheap printer, but maybe you have it at home and you can do it. It's not a filament EDM printer as usual, but you will need to do it with a transparent 3D printer material. So this is a sheet with 0.3 millimeters thickness. So it's with 0.3 millimeters, and this is 45 millimeters long. So this extrusion is 45 millimeters long, and this has to have um, this shape, the most accurate shape possible, but you will have to make it by blending the shape of a sheet of a sheet. Sorry if it sounds like I don't want to, but this is only a sheet made of copper and is doing the functioning of an inverter, of an inverted microwave equipment. It's like an inverted microwave. So this will have to make here. You will have a point here where I'm aiming now, and a point here where I'm aiming right now, where you will have to give electricity. This will be the top one, the front one. So in the front of the engine, I mean, you will have the positive one, and here you will have the negative one, the negative pole. Okay, this is very important. The positive one is here, the positive side of the of the circuit, and this is the negative. So because it has this discontinuity here, the electricity will go here all around, but going through this plate, this sheet, I mean, this copper sheet. So in reality, if we had only this, we will have no effect at all, not any desired effect of a microwave or something. So we will have to have magnets, and this is I will show the magnets. These are the magnets that have to be inside the cavity. These are making the desired magnetic field for starting the engine, only for starting. So you will have the I think this is the North Pole, and this is the South Pole, and then you will have, if you have this positive here, no, if you have just this positive, for example, it depends on how do you want to do it. You could have the positive here and the negative here in this side, or the positive here and the negative here in this side. But then you will have to try the other configuration of the magnets. These are neodymium magnets with the polarity very clear, and with the North Pole in here and the South Pole in the other side. So they are very accurate magnets, and I had to buy it by a Germany company that I don't remember the name right now, but that does neodymium magnets. These are with a size of 5 millimeters. So this side here is 5 millimeters, the size of the square. And with these magnets, you will have the desired initial magnetic flux that you need to start the engine, and to the electricity to go in another way. So here it will do the thing that it has to do. Okay, so that's it. This is the magnetic field that you need, but you will have also a core. This is the core. This core is made by the same sheet plate that has 0.3 millimeters thickness and is only an spiral, and you will see this side, the front side of the engine, is completely flat, but the other side is not flat because it has to have all the engine. It has to have some asymmetry in order to the flaps to go from the front to the back of the engine. So you will see that here has a little bit of a cone shape. You can I did this in my home with the same copper sheet that I did the resonator, the RF cavity, but with a reshaped. So it's like a cylinder that I had wrapped around the magnets, and that I made here the hole for a cone that will be the heat sink. The heat sink also deviates the magnetic field, so it's very important to have a heat sink here. If not, you will have only magnetic field but not direction of the fluid. Maybe it will be useful for other applications, but I don't know for now. The heatsink is this. It's made of plates. If you can see it only without the magnets and the RF cavity, I hide also the core. This is like with this is the heatsink. Is also 0.3 millimeters thickness plates or sheets, but doing like this kind of washers, no? Like these washers with a cone shape, and this has this shape. Every washer is doing the cone, and you can see in the 3D model how it's done, with which angle I'm using and so on. I will give you the 3D models, and don't worry, you will have it in the comment sections, or I don't know where for now. And this is deviating also because it's made of steel. The core and the RF cavity are made of copper, but the heatsink is made of steel, of inox steel, because it's better to have an inox steel, and it will be very more difficult to give shape to these cones. I did it in my home with parts of plates, of sheets, so it doesn't have to be a complete cone with this perfect shape and so on. It only have to deviate in order to have a prototype. You will have to make it better than me, and I did with parts of plates. For example, this middle plate, and this middle plate, and this middle plate, and this middle plate, and I put it all inside, and with the pressure of the other parts, it is just adjusted in place. So that's it. You don't need to glue it. You don't need to do nothing. Yeah. You don't have to use glue if you can avoid it. It's better to not have not use glue or any other thing, because it could be with the heat, it could be dangerous. So this core also is a sheet. You will see that is the same sheet, no? And you have to have this rounded shape where you can see that you have these plates that will be resonating with the RF cavity, that is making the magnetic and the electric field. So with this in place, you will have all the things that you need to do the engine. And this is only an explanation of the fabrication of the engine, so you can do it at home. But you will have more data in my profile or whatever I do instead of this video, because in this video I think it's not very well explained. So you will have this. You can glue only, if you want to, these magnets in place. So you can have there the magnets are making 45 degrees with each other, and the North Pole is in here, in here, in here, in here, in the green shapes. No, sorry, in here, sorry, here in this place, 45 degrees more, 45 degrees more, 45 degrees more, 45 degrees more. You see the pattern, right? Till the last, that it will have also the same as this one, the same polarity, because they are exactly 45 millimeters long. I think I said 40 millimeters, but it's 45 millimeters, I think. Let's say if I can. Yes, 45 millimeters. So you can have these 9 magnets of 5 millimeters each, and you will have to have 9. You have also to have these 9 cavities because it will have to work with an impaired number of cavities, and so on. So that's it. That's the thing I wanted to tell, to fabricate to make it more, if I could. I don't think so. To make it more visually attractive, the task to make an ion engine is different than the other ion engines. Now I will sell my invention, because it has this, let's say, magnetic fields that interact with the charged particles, and has a cycle that makes the ion engine work in this resonant mode, sorry, and that you can do it to have a better performance in the engine than and it's very different than other ion engines that are actually in use, that only consists in one grid and another grid backwards, or I don't know what's the word now, but in the path of the flux of the fluid, you will have only grids of polarity, of a positive polarity and negative polarity, and it will ionize there and go through the other pole, ionized part, or not ionized. The other pole will have a magnetic no, an electric field, and you will have to accelerate the fluid in this side. But this is having a magnetic field and making a sliding. The particles I'm making a sort of slalom in this magnetic field that it produces. you will have you have now no proof if you have seen only this video of these things that I'm telling, that you have a magnetic field, a radial magnetic field, and electric field in here in the an axial electric field. But you have all other videos that I have, and I will publish in my channel or whatever I do, where you can see that I have produced a magnetic field, a radial magnetic field, and an electric field. So you will have their proof in this one. Materials that I recommend to use this to do this ion engine. Of course, the resin, the 3D printer, the resin 3D printer. The resin have to be transparent. This is very important. A transparent resin that also, if it handles more higher temperatures, it will be better. No, right? Because this will get hot, and I don't recommend to use a higher voltage than 100 volts, and be very careful with the voltage because this is a resonant circuit and it will fry some things if you are not very careful. But I have not passed through 12 volts. Up to 12 volts, for me, the engine got stuck and the magnetic field is not produced correctly, and the electric field is not produced correctly also. So if you can achieve more than this voltage, and significant amount more than this voltage, you can contact with me and say, yes, I did an ion engine that, for example, makes flux. For example, if you have more than 50 volts, I think the flux will be visible. You can use dry ice, for example, to make to see if the fluid is correctly propelled. Here, this is the front side. This is the front side, and this is the back side. Okay. So you will have this this thing, this let's say this. I don't know. I will edit this video maybe, but maybe even I don't edit the video. I'm not very good at making videos. I'm shy, and sorry if it's not very well done or it's not very funny, but it's like it is. I could do it in Spanish, and I will in the comments or in whatever section, if you want to contact me with no, if you want to contact me with the email of something or something, you can contact me, and you can of course, if you have any doubts, you can question me and I will answer, because I'm the first person interested that you have this prototype working. And then this prototype, I wish to do it with a free license with Creative Commons, so everyone can do the engine and even profit of it. So it will be like if it works well, it will have to have other versions, other better versions. You can do it full metal with more size, because this is very scalable. Sorry, you can do it with a lot more size, because for now, for example, you will see that this is only I don't know how to measure here in this program, sorry. But this is like 45 millimeters or 50 millimeters long, the core. So you will have this of let's say 100 millimeters diameter, this in this outer shell, but this is this has not to be very accurate. The outer shell, this outer shell, the ferromagnetic outer shell, doesn't have to be very accurate, and you can have other shapes and other stuff, but you will, I hope you will find this interesting and that you will even improve or maybe do it with other materials, or but first I will recommend you to learn the basic, to figure out how it is done and how it's working, and if you do it, you will be rewarded with another type of ion engine. I hope this will reach the most people possible, and that you will find it attractive, and that you will do it with care, because if not, maybe it doesn't work correctly. But that's it. The important things: the magnet, the core. That the core is not, it has not to be very accurate. The heatsink doesn't have to be very accurate also. You see that I did a little bit of plates in like in a conic way, and the core flux, the core nacelle and the nacelle, you will have the STL files, so you will have to print it in the 3D printer. The RF cavity is the most difficult part, this part, and it will have to fit in the core flux nacelle. So if I do this, no, sorry, this one, it will have to fit like this. You can see it here, it's fitting perfectly, but it doesn't matter if you have 1 millimeter less or more, because I had more than 1 millimeter in some parts, more than 1 millimeter difference, and still it worked up to 12 volts. Of course, the magnets is another important thing that you will have to figure out how is the polarity, because if you put, sorry, I cannot change here. If you have these magnets, you will see that it's aligned with the part or the place that I can see now. Here is aligned the first and the last magnet. This magnet and this magnet has the polarity in the same direction and is perpendicular to this opening, the opening of the RF cavity, this RF cavity. This opening is very important, and this is why it's made of one sheet, one blended sheet of copper. So this is copper, the core is made of copper, the magnets are the neodymium magnets, and the heatsink is made of inox, of steel, steel inox. Maybe if you don't understand something, this is meant to be more an explanation without the other instructions that I will give, and maybe to open your appetite to make the thing to be more funny, or I don't know. But I think this is heavy stuff, so it's not very I don't know how to say it. I think it's not easy, and this is what I meant to say. And I use to make the signal work, because here you will have, I will send you photos of how I made the contacts that are going to the RF cavity, to the radio frequency cavity. And these contacts are two needles in my case that are here and here, or in the place that is the opening in the RF cavity that I don't see now. And these contacts are in contact with a circuit that has a signal, a sort of signal that I will be giving to you, and is made of a frequency of 180 Hertz that is perfectly achievable with a speaker and an amplifier. So you will have like a music archive, a music file, I mean, and with this file you can amplify with an amplifier and make the engine work with this frequency that is in a file that you will have. This file will contain the let's say the starting part of the signal, and then it will convert to 180 Hertz or this frequency. So you will have to make this signal. But maybe if you see this interesting, if you achieve any field and you find this attractive, maybe you can train starting with my signal, my type of signal, that is the theoretical signal, but maybe it's wrong. You can try to, by using an artificial intelligence or something like that, you can try to train some artificial neural network to make the signal more efficient and to propel even more fluid. So this will make maybe the ion engine more efficient. I don't know. I have to say also that this is not an invention that is easy for anyone, but I am an aeronautical engineer, and I've been at CERN also, and I've been seeing, I like physics, astrophysics, quantum mechanics, so it has a little bit of many things, but let's say that I'm not a naive person, and this is not made without a purpose. I will not give the exact explanation, but I could consider, if you make this engine, I will consider you to maybe make a further collaboration, or maybe make something better to make these engines in full metal, or to improve these engines. So I only need this. I'm sorry for if it seems a little bit I don't know what's the word right now, but I only need this in order to prove that my engine works. But the thing is, if you prove it, if you make it at home, everyone will have this engine available. So it will be a free engine for everyone. Everyone could have the rights to make it. Only will have to mention me as it made in the Creative Commons agreement, and that's it. It will have I will make all other videos to to further explain, but this is where I'm going to go. Okay, so bye, and maybe I will not repeat this video, but this is the first shot. So maybe it's better to do it in another video to explain it better, but I will have not very much patience to have it, to do it, and time to do it. So I hope you is interesting to you guys, and I hope you find it so interesting that you can do it at home. And good luck if it works. It will be a very good news, but because it's an ion engine that it has the potential to become like a reactor engine, like a chemical reactor engine, but with electricity. So it's for electric flight in an atmosphere or in another fluid that may not be the exact wind. So maybe in water also could be useful. You could experiment with this if when you have done it. You could experiment with this in other fluids other than air, and maybe it's working. So let's say that I hope it's interesting to you, and I hope you have good luck and it's working. Goodbye, and we'll see you later.